when we take the limit as x approaches 9 of negative 5, we're saying when the x values get closer and closer to 9, what are the y values getting closer and closer to? Well, if we take the limit of a constant, the y values are constantly going to be the same, so therefore the limit as x approaches anything of any constant is just the constant. So I just drew that graphically over here so you could remember from our last lesson what we're looking at. So then for number 2, the limit as x approaches negative 10 of x. So x is a polynomial function. It doesn't have any breaks in the graph, so the limit of a polynomial function is just, we always just try replacing x with whatever x is approaching, and so we see that the limit as x approaches negative 10 of x is just negative 10. And then when we take, for number 3, we take the limit as x approaches 6 of negative 7x minus 4, which is also a polynomial function. So with polynomials, we just replace x with whatever x is approaching. We get negative 42 minus 4, so we get negative 46. Same with number 4. So number 4, polynomial function, limit of this function as x approaches 4 is equal to 4 squared minus 4 times 4 plus 6. So 4 squared is 16 minus 16 is 0 plus 6 is 6. And then, so up until number 5, all we're doing is we're just replacing x with whatever x is approaching. This one's no different. 10 squared is 100. Negative 15 times 100 is negative 1500. Now, number 6, you have to be a little bit more careful when we're dealing with non-polynomial functions. But if we look at this function here, as long as we can, this is a square root function, as long as we can replace x in a square root function, we know square root functions, the parent function looks like that, y equals the square root of x. We know they don't have any breaks in the graph. So that's what we're really concerned about, are there any breaks in the graph? And if we replace x with 1 in this function here, we just get 3 times 1, which is 3, minus 2 under the radical. 3 minus 2 is 1, so we just get 1. So the function exists at x equals 1. And as long as we get a number besides 0, then we don't really have to blink an eye on finding a limit of a square root function. And then number 7, we also have to be careful with fractions, so rational functions like this, that we don't get 0 over 0, or we don't get 0 in the denominator. And as long as we get a non-zero number in the denominator, then we're okay. We can just substitute in whatever x is approaching. So 2 times 1 minus 7 over 4 times 1 plus 5. 2 minus 7 is negative 5. 4 plus 5 is 9. So negative 5 over 9 is our limit for number 7.